Wordle has become a massive hit. The simple word game was released in October of last year, going on to become a Twitter sensation, later being acquired for north of seven figures by the New York Times. It's been my daily addiction lately, and today we're gonna build it. Before we jump into things, start by destroying that like button down below. Leave your Wordle answer of the day in the comments down below. If not your answer, then your game board. Don't spoil it for everyone. Let's jump into Xcode and let's build Wordle. All right, we're gonna go ahead and get started by opening up Xcode, creating a new project. We'll stick with the app template under iOS, and we'll go ahead and call our project Wordle. We'll stick with the Swift language, and we're going to be working mostly programmatically in UIKit today. So we'll stick with storyboard, create that project, toss it wherever you'd like, and let's jump into things. So first and foremost, let's pick a simulator since we're going to want to visualize what we're building iteratively as we add stuff. So I'll go ahead and pop up a simulator right there, and we'll see our empty application. So the Wordle application, in a nutshell, the main mechanics are fairly straightforward, and we're going to essentially have four files. So I'm going to create two folders on the left-hand side here. The first one is going to be called core, and this is going to basically house all the code we're going to write. And then I'm going to create another folder, and we're just going to call it other, and this is going to be basically most of the stuff that we are going to completely ignore. So things like your storyboards, your app delegate, things of that nature. So let's go ahead and do that, and let's start talking about the main architecture of the Wordle app. So traditionally, there is a top section, which is your game board, and you have a makeshift keyboard at the bottom. We don't actually leverage the system keyboard. So we're going to want to keep those two components separate. So we're going to use child controllers. So first and foremost, let's go ahead and create two UIViewController subclasses. The first one will be the keyboard controller. And then the second one here is going to be, maybe we'll go ahead and call it a board controller. Let's try that one more time. We're going to do new file. We're going to create a subclass, and we'll call it a board view controller. Now, to make sure that this video isn't all over the place, we're going to go in order. So let me just jot some notes for myself here. So we're going to do the UI first. We'll hook up the keyboard interaction thereafter. We'll hook up the game board, and then we're going to hook up the color. So in Wordle, as you might be aware, if your letter exists in the word but is in the wrong slot, we're going to have it show orange. If it's in the correct slot, the correct position for the answer, we're going to show green. So we're going to go in this order. So now that we have these two controllers here, we're going to go ahead and just delete all this nonsense, and we're going to start by giving this guy a background color so we can at least start to visualize things. So I'll make this one red here in our keyboard, and in our board controller, we're going to go ahead and make this one a different color. Perhaps we will stick with blue. Let's go ahead and delete all of this nonsense. And let's go back to our app's primary controller. So inside of here, we're going to start by setting a background color for our app. Wordle is traditionally a dark theme, so we're going to go ahead and use gray 6, and we're going to create a function, and we're going to go ahead and call it add children, and we'll call it inViewDidLoad. And this is essentially where we will go ahead and add our two child controllers, being the keyboard VC and the game board VC. So we're going to go ahead and create those up here. So this will be our keyboard view controller, and right below it, I'll just copy and paste it and change this guy to be our board view controller, like so. So the first goal that we're going to have in this project is to make sure everything is functional before we, invest too much in view models and architecture and cleaning everything up. And debatably, I might actually leave that for a second video. So just a disclaimer up front. So we're going to go ahead and say add child, and we'll do the keyboard one first. When we add a child controller, we need to tell the child controller that you have moved to a parent, in this case self. We also need to go ahead and add the sub view from this controller, and we're going to be leveraging constraints to actually hook up the UI and in terms of laying out these views. So we need to actually say translates constraints auto resizing mask constraints into constraints to false. We'll go ahead and assign that here. Let me collapse this left panel while we work on this to give ourselves a little more room. And we'll copy and paste this for our other controller as well. And just go ahead and change all of these. Just be careful when you copy and paste. Sometimes you can make a silly mistake. I'm definitely guilty of it. So the next thing we want to do after adding these children is add constraints. I'm going to do that in a separate function just to keep things nice and organized. So if we go ahead and give our app a run right now, what you'll notice is one of the child controllers will probably show up, which is the blue one in this case, but we want the top to be our game board, which I believe is blue, and we want the bottom to be the red, which I believe is our keyboard. So let's go ahead and say ns layout constraint, and we want to activate, whoops, we don't want an anchor, we want a constraints, and we're going to activate a variety of constraints. So let's do the board VC first. We're going to say its views leading anchor is going to have a constraints equal to this controller's views leading anchor. We're going to copy and paste it a few times for the trailing, top, bottom, and heights. And similarly, we're going to want to do the leading, trailing, and bottom for our keyboard. So let's do the keyboard since we're down here already. We'll do the keyboard VC and we'll change all of these. We'll want to do the leading, trailing, and the bottom like so. And we'll change bottom here as well. And respectively up here, we'll make this guy trailing. This will be pinned to the trailing of its parent view. We'll also do the top anchor, and we'll pin this to the top. We also want the bottom anchor of the board VC, so the top view, to be touching the keyboard VC's views top anchor. In other words, the bottom of the top piece will touch the top of the bottom piece. Now finally, this part's really important. We want to actually give a height here so we can actually have auto layout calculate the heights of these various views. So we're going to say this is going to be a constraint equal to something with a multiplier. It's going to be equal to the height of our parent view with a multiplier of 0.6. So if you go ahead and give that a run, let me just add my comma here that I forgot, we should now see a red controller at the bottom and a blue controller at the top. Now, one thing that I want to take note of, we're not respecting the safe area in terms of underneath the notch as well as the home indicator at the bottom. So what I'm going to go ahead and do here is update this to use the safe area layout guide. That way we're not going to actually have any of our UI be cut off. And similarly for the top anchor up here, I'm going to adjust this as well like so. So go ahead and give that a run and we see our blue section and our red section. So looking pretty good. The beauty of this child controller approach is now we can hop into our keyboard view controller and we can build this piece in isolation from everything else. So how is our keyboard going to work? Well, essentially we're going to be leveraging a collection view that we will horizontally center to show our various keys. So we're going to want a collection of characters, and I'll go ahead and call it keys, and it's going to be a 2D array like so, but instead of filling this out by hand, which is a tad bit verbose, what we're going to go ahead and do is define our letters. And what I'll go ahead and do is just do basically the keyboard. So the top will be Q, W, E, R, T, Y, U, I, O, P. The second row will be this guy. I'm literally just hitting my keyboard at this point like a crazy person. And then the last row will be this here. And we're not going to handle the backspace in this video. We can add that perhaps in a future video, but this is the extent of our keyboard that we care about. Now, in terms of actually laying out our collection view, we first going to create that collection view. So let's go ahead and create a pretty basic collection view here, and we're going to need to tweak it to make sure it looks and feels exactly how we want it to look. So we'll basically go ahead and create this guy here. We need to pass in a frame as well as a layout. We're going to create the layout up above momentarily. We'll just return this here. And we're also going to pin this with constraints, rather lay it out with constraints, I should say. So we want to make sure we don't forget to set the auto resizing mask property to false in here as well. Let me collapse this left panel so we can actually see stuff a little more easily. Let me create that layout up here as well. So this is going to be a UI collection view flow layout. In this layout, we are going to say that the inter-item spacing is going to be perhaps 2. You can tweak this number to find whatever you think looks best, but we're going to stick with 2. And in terms of the background color for this collection view, let's go ahead and just give it something random so we can actually see it. Maybe we'll go with yellow, and this should be color, not view. Bear with me. All right. So we got our collection view here looking pretty good. We never registered a cell to it. That's because we haven't created a cell yet, but we'll do that momentarily as well. Let's go ahead and add this as a subview. And we also are going to want to set up its delegate and data source. Let me hold off on that for just a moment. Let me add some constraints here. We're going to go ahead and say that its leading anchor is going to be equal to this view's leading anchor, this view controller's view. We'll copy and paste this a few times because we're programmers and we're lazy. And we're just going to change up all of these. Just make sure they are related to one another. Sometimes I've screwed up my copy and pasting. And by sometimes I mean very frequently. So let's go ahead and before we actually go ahead and give this a run, we need to set up that delegate and data source. But actually, in fact, even before we do that, let's just give this a run and see if our collection view shows up. And there it is. It in fact does show up. So now that we've got that collection view that's yellow, let's actually set up its delegate and data source. All right, so we're gonna assign its properties, and we are going to momentarily need a collection view cell. So we're just gonna go ahead and create it before our program yells at us and tells us that, hey, we actually need one to DQ. So we'll go ahead and create one of these. I'm just gonna call it a key cell, and this is gonna represent a key in our keyboard, as well as we're gonna reuse this for our game board. So on this key cell, we can go ahead and add a identifier. We're going to leverage this identifier for our actual registration. Before we jump onto the cell, let's actually register the cell and get it to show up. So let me go ahead and collapse this again. Now let's go back up here to our collection view. We're going to go ahead and say, go ahead and register the key cell.self with the key cell.identifier like so. We're being yelled at about the delegate and data source because we haven't conformed to the protocols yet. So there is our delegate for the flow layout, which we'll want as well. We also want the standard delegate for the collection view. And finally, we're also going to want the UI collection view data source. We'll want to conform to all of these protocols respectively. Let me do it in an extension down here just to keep things nice and organized. So the first thing we're going to want to do is number of sections. We're also going to want number of items. We are going to want to actually DQ a cell. So we're going to say cell for item. And that's not what we want, cell for item like so. We're going to want to handle the size for an item. So we're going to say size for item. We are going to want to define the inset, the section inset for each section, since we want to center each of our section rows. And finally, the last one we're going to want is handling a tap on our actual cell. So these are the functions that are going to basically power the majority of this keyboard component. Let's actually go and fill them out. Now, before we do that, we can come back to this. We created letters up here, but we still have keys as an empty two-dimensional array of characters. So we're going to create keys by looping over letters. So what I mean by that is we're going to say for row in letters, since letters is a single dimension array, we're going to create our characters by simply wrapping this row, which is a string, in an array, and this will give us a collection of characters, and we can say keys.append characters. And that's all we actually need to do to get this working. Let me make sure my strings are correct up here. So this is QWERTY UIOP. This looks correct as well, and this looks correct as well. So now in number of sections, we can simply return keys.count. In terms of number of items in a section, we can return keys at that particular section.count. For our cell in question, we want to DQ from our collection view the key cell that we have registered. So we are going to DQ a key cell dot identifier for that index path. We are also going to cast it. And finally, we are going to return key cell like that, rather just cell is what we called it. In terms of our size, let's just give this a hard-coded value before we actually compute this properly. For our section insets, maybe we'll start with 0. And for selection, we're going to leave this empty for a quick minute while we actually handle our UI. So cool, so we don't really see anything down here, and the reason for that is all of our cells don't really have a background color, so let's go back into our cell. Let's actually set a background in the initializer here, so I'll go ahead and override said initializer, and maybe we'll go ahead and set a background color in here. Let's try that one more time. A background color, and maybe we'll do something like system gray 5, which should be a bit of a lighter gray color. And this is yelling at me that we need to bring in the other initializer for a coder. And just like that, we see a bunch of these squares. They look super ugly. So let's actually work on making the size proper and getting the letter to actually show up on the key. So we're going to go back to the keyboard view controller, and we're going to actually deal with the layout and the sizing. So the first thing we're going to work on is the size of this cell. The size is fairly straightforward. What we really care about is the row with the most number of elements is the top row, the row that starts with QWERTY. We have a total of 10 elements in here, and we know the inter-item spacing between each element is 2. So we know that we have a margin of 20. Now we also know that we are going to take the entire width of this collection view and we want to divide it by total number of cells in a particular section. So we're going to go ahead and say that the size for a particular item is going to be the collection view .frame.size.width subtracting the margin divided by 10. And we can toss this size in both the width and the height and give this a run. And let's see what I have screwed up because something's not happy here. So we have said this is a CG size where it should be a CG float. And let's see, we're returning this here. We want the return keyword just like that. And now we should have proper sizes. Now, they are proper. One thing that we want to go ahead and do is perhaps increase the height and add some spacing between each of these rows. The way we're going to add spacing is by using section insets. So we're also going to use section insets to center our keys. So before we talk about centering, let's at least get the top and bottom parts of our insets worked out. So for the top, I'm going to go ahead and say perhaps 2. From the left, we could say 0. From the bottom, maybe we'll say 2 as well. And from the right, we'll say 0 as well. And let me just go ahead and line break all this good stuff and give it a run. We should now see some vertical spacing between each of these rows. So looking good. If you want your key to be a little taller like I do, maybe we can multiply this by 1.5. Now the next thing that we're going to want to do is actually make these rows be centered. Now we could subclass the flow layout and go pretty deep into doing it that way. However, that ends up being a tad bit complicated, so we can be a little more intelligent about it and compute our left and our right insets based on the number of elements we have in a section. So we're going to do that here, and it sounds a lot more complicated than it actually is, so bear with me. So we're going to create left and right here, like so. We're going to make left here and right here. And if you think about it, what we want to calculate is how much space is our margin and our cell taking in. So we want to get the gap here and divide that by 2. And that'll tell us what our left and our right inset will be to center basically horizontally that row. So the way we can get the count of items is by saying collection view number of items in section. We literally have our data source, so we can simply call upon it and say, hey, how many sections or how many items do we have in this particular section? Now I'm going to go ahead and cast this as a CG float since we're going to need that for all of our computations. Now we also know our item size up here and our margin. So I can be lazy and just copy and paste it down here. We have our size and we also have our margin. Now we also know our total width of the collection view. So what we can do from here is we can calculate the margin. So what we're going to say is that the inset is going to be a CG float. And the first thing we're going to want to do is get the entire width of the collection view. Now from this, we want to subtract the item size multiplied by the count. And we also want to subtract 2 times the item count. Since 2 is the inter-item spacing, This whole thing we're going to divide by 2, and this should be our inset for our left and our right. We'll just go ahead and assign these right here. Go ahead and give this a run, and it should be centered just like that. Beautiful, looking great. So the next thing that we want to do is let's get rid of this ugly yellow color, since we kind of have our collection view up and running, so to say, at this point. The other thing I'm going to do is we're going to add some spacing in the top constraint here, so it gets pushed down just a smidge, perhaps 30. And we also want to have our letter show up now. So to get our letter to start to show up, we are going to go ahead and add a label to our cell. It looks like the collection view's background color is still showing up as black, so we're going to explicitly go ahead and say that it is going to be set to clear. So let's go ahead and give it a run, and there is our keyboard looking thing. So let's go into our key cell and let's set up a label. So we're going to create a label in here. It'll be of UI label type. That's not a label, that's a toolbar. And inside of this anonymous closure, we'll simply go ahead and create it. We're going to be using constraints in here as well. So we're going to go ahead and set this property. We'll return the label, and we're just going to do a little bit of stylistic work. We're always going to be in this dark theme, so we'll have some white text color. We are also going to want this to be centered, and let's go ahead and actually give it a nice font as well. Maybe we'll stick with a system font of 18 size and medium weight. Next up, we want to actually go ahead and add this as a sub view, so we'll add said label, and we're going to go ahead and actually constrain it. So we'll say activate some constraints, label leading, and this will be constraints just like we did for the collection view. So we'll say this is leading as well. Let me go ahead and just copy and paste this 3 more times, and we'll go ahead and tweak these. So this here will be trailing, this will be trailing as well, this will be top, this will be top, this will be bottom, and finally this will be bottom. Now we actually need a way to assign the letter, so we're going to add a function called configure with letter here that'll take in a character. And once we have that character, we can say labels text will be string of that letter, and we're just going to uppercase it so everything looks nice. And every time this cell is reused, we want to go ahead and nil out the text on that label. So we'll just say the text on the label is nil. So if we go ahead and give it a run, you actually won't see anything because we haven't actually called that configure function yet when we dequeue the cell. So back in our keyboard controller, the way that we do this is by simply saying cell.configure with the letter. The way that we get the letter out is by saying from keys, give me the thing at that particular section, and give me the thing at that particular row. Go ahead and give it a run, and we should now start to see our actual letters appearing. So this is looking pretty good. The next thing that we want to do is hook up our UI for the game board up here, and then we can talk about interaction between, actually tapping on these letters and seeing something happen in our game. So let's jump on over to our board view controller and talk about what we need to do in here. So it turns out that the keyboard component and the board component are actually really similar. And they're so similar, in fact, that we can actually get away with copy and pasting 90% of the stuff in here and just tweaking it for our needs. So we're going to copy it. We're going to come into board controller, and we're simply going to paste it. Don't forget to change the extension down here since we extended the keyboard controller. And let's actually talk through what this needs to look like. So we want all these delegate and data source conformances, but the Wordle actual game board has 5 characters in a word, and you can guess 6 times. So we need 6 rows, and we need 5 elements in each. So instead of this letters and keys nonsense up here, what we actually need is something called guesses. And we're going to actually be creating a data source to pass this in, but just to get everything up and running, we're going to create it this way. Now, initially, we don't have any guesses, so we want the character in here to be optional. So we're going to say this is an array repeating something, and we're going to have 6 of these, so repeating 6 times. Now what's going to actually be repeating? Well, this is going to be another array, and it's going to be repeating, if I can spell it, there we go, it's going to be nil, and it's going to be a total of 5 times. In other words, we now have 6 of these guesses, and each of them holds an array of characters, which will have at most 5 elements, and each one is going to be nil before we start. Next up, we can talk about this collection view. This is actually going to remain pretty similar. We're going to tweak this a little bit. Maybe we'll do 4 here for the inter-item spacing, but other than that, all the same. We still want the delegate, we still want the data source, we still want to add it and constrain it. We no longer need this here though. Moving down to the actual implementation for the collection view, we're going to return guesses.count. In terms of the items here, similarly, we can actually just update it in place. So it'll be guesses at the section.count. In terms of the cell DQ, we no longer have a letter. So let me just pass in some random letter here. Maybe we'll go ahead and say A, like so, just to get something to show up for the time being. We're going to want to tweak this item size here momentarily. So let me go ahead and simply get rid of this centering logic that we added. Now we know that we have at most 6 elements down and 5 elements across. So let's say we have 5 here. We're going to say collection view frame width minus margin divided by 5. So let's say we have a margin of, let's say 4 between each of them. The margin will still be 20, 5 times 4. So we want this to be a square though. So let's get rid of the height calculation and give this a run. All right, so we see our board up here. It's a little obnoxiously big, and we probably want it to look a little different from our keyboard. So we actually have a nicer look and feel to it. So let's actually tweak some of it. So first and foremost, maybe we want to add a little bit of space on the left and right for each of these sections. So perhaps we'll change the sizing just a smidge. And we also want the cells to look different. So in terms of the cell, what I'm going to go ahead and do is we are going to change the background color, and I believe I made it on the content view. We're actually going to make this nil for the time being, and we're also going to want to add a border. So we're going to say that this has a layer, border width, and we'll maybe do 1. And it dawns on me we should probably do this in the view and have our view model calculated, but for the sake of this video and simplicity, we're purposely doing things here just to keep things nice and simple. So we'll add our color, our border width, and go ahead and give this a run, and our game board should look a little different, hopefully. Let's go ahead and also change this. I believe the color was on the cell itself. All right, looking a little better. Now, let's go ahead and make the game board a little smaller because it's a little obnoxiously big. So let me go ahead and see how we can go about doing that. We can actually add some insets here for the left and the right. Maybe we'll do a total of 2, just like we did the top and bottom. And in terms of the constraints for the collection view, perhaps we can adjust these a little bit. So we can say 20 from the left, which is leading, and similarly -20 from trailing, and we already have something for the top here, so we'll leave that as is. All right, so looking a little better. Maybe we want to do even a little more. At this point I'm being nitpicky, but let's just stick with this and continue along building this out. All right, so we have our game board up here. We certainly don't want it to always say A, so let's get rid of that configuration call, which is right up here. And we should see our empty game board. And this brings us to the next and exciting part of this video, which is the actual interaction. So when I tap on one of these letters down here on the keyboard, we should actually update the game board. The way we're going to do that is by leveraging a delegate. So the idea is we're going to go into this keyboard component, and we're going to create a protocol. So we're going to create a protocol, and this is going to be a delegate for this particular controller. And we're going to have one function in here, and that function is basically going to notify whoever the delegate is hey, that this letter was pressed. So we'll say this keyboard view controller, and let me just go ahead and line break this for readability purposes. And we're going to go ahead and say did tap key. And we're going to also pass in the letter for the character that was tapped. Respectively, we're going to want an instance property that's weak on this controller that we can actually work with. And whenever a key is pressed, what we want to do in the collection views delegate is we want to do a few things. We first want to say, hey, go ahead and deselect that key, that cell, so it's no longer highlighted. But we more importantly want to call our delegate and pass along the letter that was pressed. How do we get the letter? Well, we already know because we have the index path. But from keys, we can once again get index path.section. And in here, we can get index path.row and pass that guy in. Go ahead and give it a run, and whenever we tap on this, we're passing back our letter. The reason nothing is happening is because we haven't actually set that delegate property. So let me go into the view controller file here, which wraps all of our components. And what we want to do is when we created this keyboard VC and set it up, we're going to now also say, hey, I'll be your delegate. So we're going to say delegate is self, and respectively, what we want to go ahead and do is we want to conform to that delegate so we can actually get those interactions. So we'll conform to that protocol, and then we'll bring in that function. So now that we've brought in that function, let's go ahead and simply print out the letter that we are getting back. All right, so I'm going to go ahead and press Q, and we should see in our console the letter Q. So let me just open this up, go ahead and tap on Q, and there is, in fact, Q. So the next thing that we want to do is we want to pass this data along to the board, or we somehow want to tell our board, hey, go ahead and reload yourself with this updated data. And that brings us into the interaction model for the board here. So instead of housing the guesses collection within here, the more appropriate thing to do would be to get it from a view model or get it via some data source. So what I'm going to go ahead and do is we're going to create another protocol inside of here, and we're going to say that this is the board view controller data source. And essentially, all we really care to get from this data source is the guesses. So we're going to say current guesses is simply going to be a computed property that'll return to us the same thing as what that we have defined down there. It'll be a get only property. Now what I'm going to go ahead and do is we're going to move this guesses collection into our top level container view controller. We'll also make it private. And for the sake of this video, we'll go ahead and add an answer here as well. Perhaps the answer is going to be the word after. And this is what we're going to test our game with. Now that we've made that change, if you go back to the board controller and try to build your project, you're going to have some errors. And that's expected because down here, we've said number of sections is use guesses directly and get the count. But we don't have guesses anymore. What we have is our data source, and we actually haven't even defined that property up here. So for this protocol, we're going to create a property called data source and stick it on here just like a delegate. Now down here, we can say, go ahead and get the count from the data source. Like so. If you're not able to get it, it's going to be 0 since our data source is in fact optional. Similarly, from here, what we can do is get this from guesses. We'll say guesses is going to be our data source dot current guesses. Otherwise, it's going to be an empty collection just like that. If you try building, you'll see that everything will build once more. But if we go ahead and give it a run, what you'll notice is we don't see a board anymore. And in fact, we see a bunch of nonsense in my console here. It's not relevant, so let me close that. The reason we don't see a board anymore is because we never, in fact, assigned the data source. So back in our view controller, we're going to say where we set up our board VC, I'll also be your data source. So similar to how we extended this down here, we'll copy and paste that, and let me actually do it below the keyboard to keep things organized. And here we're going to go ahead and say that this is the board data source, and the only thing in here that we've got so far is current guesses, and in here we can just return guesses. So go ahead and give it a run, and you'll notice now we once again see our board, and let me close this console. That is completely irrelevant. Bear with me here. I'll just collapse this down here. We now see our guesses. So now we have an easier way when a keyboard key is pressed to actually update these guesses and tell our board controller to reload itself. So to tell our board controller to reload itself, it's pretty simple. We're just going to add a function on here called, very creatively, reload data. So we'll say reload data. And what we're going to go here and do is say collection view, go ahead and reload yourself. And the reason we're doing it here and not on the collection directly is because we're going to keep this guy private. Back in our controller, what we want to go ahead and do is when we tap on a letter, we're going to want to update guesses, and we're going to want to then tell our board VC to reload itself. To update guesses, we're going to have a Boolean that starts at stop. We're going to have a Boolean called stop that is going to start off as false. And what we want to go ahead and do is we're going to say for I in 0 up until guesses.count, and for j in 0 up until guesses at the ith position.count. Whoops, we want .count here. We want to basically go ahead and loop and check, get the position that is nil at that next value. So this here should be up until, just like that. So we're going to say if in guesses at I and j, this thing is nil, this is where the next character, the key that we pressed, is going to go. So what we can do is simply say guesses at I and j is now letter. We can break from this for loop, and we're also going to say here stop will be true. And finally, since we call this break, it'll actually only break out of this for loop. We don't want it to continue again. So we're going to say if stop, we can break again. And now if we go ahead and give it a run, when we tap on a key, we should see it reflected in our board. So if I tap Q here, we should see it reflected, and we're not actually seeing it. And the reason we're not seeing it is not because we aren't updating guesses, but it's actually because we're not configuring the cell in our board controller. So if we come back to our board controller where we DQ our cell, we never actually set the letter. And the reason we didn't do that is because we need to actually check, hey, do I have a letter? And the way we actually go ahead and do that is by first getting the guesses. And the guesses is going to be, once again, data source.current guesses, otherwise it'll be empty. Then what we're going to go ahead and do is say if let letter in guesses at index path dot section and at index path dot row in that inner array. If we have a letter, then we can go ahead and configure the cell. So we can say cell configure with letter. So now when I go ahead and tap on Q, we should see it appear. So look at that, pretty cool. So if I type in, let's say QWERTY, if I just keep hitting letters, it's actually intelligent enough. The way that we've set it up is intelligent enough to go to the next row, and it's not going to have any out of bound issues, etc., etc., etc. We might have an issue at the very end here, but it looks like we actually don't, since we guard against the boundary. So that's looking pretty good. Now that we've got the semantics set up, we need to deal with the logic of whether or not what you're guessing is correct or incorrect. And we also want to show, once you fill out a whole row, the slots where you've entered a letter that's in the word, but in the wrong position as an orange box, and if it's the correct letter in the correct position, a green box. Now, to do that, we essentially need to do a few things. We need to figure out at every reload what the background color is for each of these cells in our board. And to do that, we're going to extend our data source. So in our data source, we're going to say, hey, let me know what the box color is at a particular index path. And we'll just pass the index path and expect to get an optional color back. So what I'm going to go ahead and do here is down in the DQ function, we are going to say that the background color, instead of just being nil, it's going to be data source box color at that particular index path. And back in our view controller, we now need to add this function and specify what that color is going to be. So just to, before we get started on this function, just to demonstrate what this will actually do, let's just return orange, and let's spell orange correctly. And you'll notice our whole board is this obnoxious orange now. Now we want it to be orange whenever we filled out an entire word and we don't have the letter at the proper position. So what we're going to do is a couple things in here. We want to do a bunch of checks. The first check we're going to do is there even a letter at the particular position? So we're going to say guard let letter, I should say, in guesses, and this is going to be at index path dot section and index path dot row. And keep in mind, if we don't have a letter, essentially what we're going to be doing is returning nil, since it's character optional, as we added up here, right here. So if it's nil, we don't want to return an actual color because nothing's there, which is kind of silly. So we're simply going to return nil. Next up, what we want to do is if a letter is there, we want to know is if that letter is in the proper slot, return green, otherwise return orange. So for that otherwise, we're just going to return orange down here. And what I can go ahead and do is we can say in our answer, which is this string that we've kept up here. Let's see if I can find it. There it is, the word after. What we're going to do is we're going to say our indexed answer, which will basically convert the string to a character array. So we'll toss answer in here. We're going to say that inside of this, if the answer at index path dot row, let me go ahead and lowercase that. If index path dot row, the letter in the answer at that position matches the letter, then we can go ahead and return system green. Let's go ahead and give this a run, and there's actually 2 errors I see here. So let's see, we have indexed answer, so we need to actually use this down here instead of answer. We have 1 error that I see, and that is we only want to actually show the colors when we're done typing in the whole word. So let's say I type in the letter A. You'll notice that it shows this grayish color, and let's see why it does that. It should be system green instead of gray like I've done here. You'll notice that the colors will start reflecting as soon as you type. So if I start typing in, let's say, alter, you'll see that the L exists in the word apparently, but is at the wrong position. Let's see what word I picked. I don't recall, so it's after. So this is incorrect. We don't even want to show that. But we shouldn't actually be showing colors while the user's typing, because that's kind of strange. We only want to show colors if the characters in that particular row are completely filled out. So what we can do is we can get the actual row by saying the section, or we'll call it row index perhaps. Row index is going to be index path dot section. And what we're going to do here then is say count is going to be in guesses at the row index. Go ahead and compact map everything, which will get rid of all the nil elements. And we're going to go ahead and say guard that the count is equal to 5. We're only going to return a color if the count is 5. Otherwise, we're only going to return nil, which is going to essentially just show the empty background color. So let's see what the problem is here. So we're compact mapping here. So we want this to be this dot count, like so. And let's go ahead and start typing something in. So if I type in, let's see, L, A, T, E, and when I hit R, you'll notice it then updates. So it says we have an L, we have an A, and we have a TER. So something is still slightly strange here because we have the TER in the proper slot. We definitely have the A, but we have no L in that word. And the reason we're seeing orange there is because we're falling back. So what we want to go ahead and do is we actually want to guard that the letter exists within that word. So let me actually move this indexed answer up here. We're going to not only check if a letter exists, but we're also going to now check that, hey, does the indexed answer even have the letter that the user has guessed? So we're going to say this contains letter. Let me just fix my typo here. Go ahead and give it a run, and let me now start typing in later, and we shouldn't see the actual L become highlighted, and in fact we don't. We see that the TER is in the proper slot for the word after, since that's our guess here, and we see that we have an A in the word, it's orange, but we're missing something. So let's go ahead and type in something totally random. Let's do some other word to make sure that it's working. So if I type this in, we see we have an E, but everything else is, in the incorrect slot. And finally, let's type in the correct answer. We'll go with after. And boom, we have now just won Wordle. We're the greatest Wordle champions in the world. And in fact, you've actually built out Wordle at this point. So let's take a step back and talk about how we can extend this. Now, in Wordle itself, we have some nice animations. When you actually pick a key, the letter actually flips. When you get the correct word, the letters actually bounce. In that case, we would just need to animate our collection view cells, which is fairly straightforward to do. If you guys are interested, let me know in the comments down below. I can always do a follow-up video. The other thing we probably can and should add is a backspace button to actually delete a character if we accidentally typed it. The nature of this game really lends itself to, taking your time, and maybe we want an enter key as well, instead of assuming once all 5 are filled in that the user wants to submit that answer. Now, before we actually wrap up here, 2 minor improvements that we're going to make today is randomizing our actual answer. So we're going to go ahead and say answers is going to be a couple different words. We can do after, we can do later, we'll do bloke. Let's see, what other words can we do? We can do there. All of these words, so long as they're 5-letter words and lowercase, I might add, are perfectly fair game. And in terms of actually getting this answer, we're just going to randomly pick an answer from that collection. So we're going to say answer will be answers dot random element. Notice this returns a nullable, so we're going to coalesce to a default answer like that, and we can actually play a game of Wordle now. So if I go ahead and guess, let's say after as my first character, apparently that was the answer. So let's try that one more time. Let's go ahead and try after, and it looks like we keep getting after. So something's actually slightly wonky here. So it looks like we get after, later. So let me actually get rid of this to make sure it's not only going to our default case. And then we'll add a nice title at the top of our game board as well. So we'll check after and we'll see that it is definitely incorrect. Let's try the game or the word ultra. Maybe that's our answer. And it looks like that's incorrect too. And there you have it. That's a Wordle. So let's get a nice title. We can do it programmatically by embedding this whole thing in a navigation controller. But since we're not going to waste everyone's time, we're going to jump into the storyboard. We're going to select this controller here. Go up to your toolbar, select editor, embed in navigation controller. And just like that, we have this up here. We can open the attributes inspector and we can give it a nice title of Wordle. Go ahead and give it a run. And we see our nice title up here and we have our game board. And just like that, you've built Wordle. Go crazy, share it on Twitter, share it in the comments. Let me know if you guys play Wordle. I've been fairly addicted to it lately, as I mentioned earlier, and I've mentioned probably 10 times at this point. Drop a like if you haven't done so already. I really wanted to do this video since Wordle's been all the rage lately, and it's what all the cool kids are doing nowadays. Yeah, and that's all I've got for you guys today. Thanks again for watching. A bit of a longer video today. Hope you guys built the final product. I'll see you guys in the next one.